So I have to tell you, I met Doug back in late March at a conference in Thousand Oaks. And Doug works for Scale Composites, Burger 10 out in the middle of the Mojave Desert, so he's a little chill big here in the wintry San Francisco. But Doug does some of the most interesting things of anybody I've talked to. I'll let him go into it, but it's just having him to have the opportunity to work with Scale Composites in itself is pretty wonderful. And, you know, working with Burger 10 and working on the Voyager and all these planes that Japan has completed or is in the process of building. So please welcome Doug Hunsaker. Thank you.
All right, like I said, my name is Doug Hunsaker, and I currently work at Scale Composites. I've been involved in aircraft design for several years. And actually, as a student, I competed in unmanned or micro air vehicle competitions. Anyway, so I've been involved in aircraft design from really small down to we had about 8-inch aircraft, and now I'm working on the Stratolaunch aircraft funded by Paul Allen. It will be the largest aircraft by wingspan in history, 385-foot wingspan, which is longer than a football field. So anyway, I feel really fortunate to be on that program. It's a great opportunity. But I want to talk today about something that I actually think about in my free time. So this is not associated with Scale Composites. I just want to make that clear. This is just something that I think about, like I said, in my free time. And I really enjoy aircraft design, but what I think about more than aircraft design on my own time is the methods of aircraft design. And I've had some thoughts about how these methods of aircraft design need to change as we move from the big aerospace history into the UAV world here that's quickly coming down the pipe. So anyway, as a background, the title of my talk today is Perspectives on UAV Airframe Design. I'd like to start off with some background on the aircraft design in general. And I ought to say here at the forefront that because this is what I've studied and what I work on and what I think about, I am a little bit biased, all right? And for some reason I think that if I admit that up front, then it's okay. So we'll find out. But if we look back over the last 100 years, from 1920 to about 1980, most aircraft design was funded by the government, right? So we had World Wars I and II that helped that along quite a bit, made some incredible progress. And at the time, not only was it funded by the government, but the methods and the aircraft themselves were extremely proprietary. We're still learning about the ins and outs of aerodynamic design, flight mechanics, and things like that. And so not only were the aircraft proprietary, but also the methods for designing these aircraft were proprietary. Okay, so about 1980 to 2000, we have general aviation and hobbyist worlds that are now growing. Things are becoming cheaper. You can build a balsa wood airframe, right? Put a gas engine in it. Anyway, so we start to get a larger user base, and now as we move into about the year 2000 to present, and these are real round numbers, as I'm sure you're aware. We have now a growing hobbyist space. We have a lot of UAV startup companies, and all these people that need airframes to do all types of things. And one major difference I see about our position today than it has been for the last 50 years is that we have many, many mission-specific airframe that need to be developed over the next few years. Yesterday, Chris Anderson mentioned the bumblebee, right, in the farm field. You know, today we're doing that with a helicopter. What if we try to do that with a bumblebee? Well, we have all types of missions, and I don't think we've even scratched the surface on the applications of UAVs over the next 50, 60 years. And we're gonna have more and more of these mission-specific airframes that need to be developed. So anyway, I think that sets us apart today from where we were about 3 or 4 years ago. And then the last thing that I want to mention here is that today it's no secret how an airplane stays in the air, right? Aerodynamics has, for the most part, been solved. Flight mechanics, we understand it very well, right? So the methods of developing aircraft are no longer proprietary. So that sets us apart here, and we have a chance now to make a change in the way that we approach aircraft design as we move into the UAV industry. So just a real quick current snapshot. This is something you're all very well aware of, but I just want to put the numbers on the board. From UAVglobal.com, they say there's over 400 UAV companies worldwide. Well, I think that's a gross understatement, right? I think you can times that by 3 or 4 and be maybe a little bit closer. Aerospace America last week put out their UAV worldwide roundup. Anyway, they list over 700 airframes in there. And then the FAA Aerospace Forecast, the 2013 to 2033, the 20-year span forecast, they say that there will be 7,500 UAS in operation within 5 years of the FAA opening up the national airspace, basically, right? So anyway, there's obviously a lot of activity going on, and inside of the United States, I believe we're actually about 5 years behind the rest of the world because of the restrictions that we're still operating under. So we're behind. The rest of the world is marching ahead, and there's just obviously a lot of room for growth here that's going to be coming up very quickly. The last point I want to make here is that the software that has been developed for aircraft design to date is either owned by the big aerospace companies or it was developed for big aerospace companies. So you see a lot of the software that's out there today is catering towards the airline industry or the fighter industry. Anyway, you look at what's out there and it's catered towards those types of missions. And anyway, so here we are at a point, I'd like to quote actually Abraham Lincoln. He says, "As our case is new, so we must think anew and act anew." So I believe we're at a kind of a dogleg in aircraft design where we have a chance to pivot and make some new decisions about how we set up the process of aircraft design. So today what I'd like to do is take a few minutes and talk about 5 key elements that I believe are going to be fundamental and really game changers in the next few years as we move into the UAV airframe development phase coming from big boy aerospace. So I have 5 things that, these are just ideas that I've had, or as I've bounced these ideas off of others, I've gleaned some ideas from friends who are also interested in airframe design. Anyway, these 5 key elements I'd just like to run through and talk about how they could impact the industry. So the first one is user-friendly software. Be intuitive, right? Who here has ever seen or written Fortran? Okay, quite a few there. And who here would ever like to see or write Fortran again in their life? Nobody, right? No, that's a little bit of a teaser because I actually think Fortran is a pretty good language. But in all honesty, what the software that we use today was written by PhDs for PhDs to design airplanes, right? You basically have to have a degree to run their software. So what I'd like to do is take the big aerospace software, and take that capability, but tune it to what I call the app revolution of what we're doing right now. So everyone here probably has a smartphone, and you've got a bunch of apps on there, right? We probably have one for your bank account, right? If you go onto your bank account app, there are maybe 3 things you can do with that. You can check your balance. You may be able to transfer funds within that bank, right, to other accounts within that bank, or maybe you can look at recent transactions, right? So maybe those 3 things you can do with your app. Well, 90% of the time when somebody interacts with their bank, that's what they want to do. So the banks streamline that and put it together in a little app to throw on your phone, right? And so they're capturing 90% of the activity with this 90% capable app. Well, if you want to do anything real with the bank, like take out a loan or transfer wire funds to another bank or anything serious, you have to go to their website, or actually you have to go sit down with them in person, right? But what I consider the app revolution is that we've streamlined the 90% solution so that it's extremely easy for the general public. And I would like to take that concept and apply it to aircraft design. Actually, 90% of aircraft design can be streamlined. And it's actually pretty, well, simple maybe the wrong word, but the method is actually not too complicated. But it's the last 10% of aircraft design that's extremely expensive that will cost more than the first 90%, right? You know, the 20-80 rule is the same type of thing. Now this graphic that I have up here is perhaps a little bit misleading. I'm not actually trying to suggest that I want an app for that, right? That we want to actually design UAVs on our phones. I'm not sure that's the best place to design an aircraft. But what I do want to show is that, that the same concept can be applied to UAV design. And if we do that, then this last bullet becomes very important. We expand the user base. How many people actually grow up dreaming about designing airplanes, right? Yeah, we've all had that thought, right? Or we wanted to be an astronaut, right? Those are kind of the two options, right? Well, how many people actually get to the point where they get to design an airplane? If this software was actually streamlined and available to people, then suddenly you could expand this user base and you could get high school students who are designing UAVs for the big players, right? You could get kids that don't have a degree necessarily that can tinker around with this and suddenly market these to the big players or the people who have the resources to actually build them and sell them. Anyway, so number one, user-friendly. We have to change the way we think about software because of how we interact with apps today. Okay, the second thing, community interaction, the ability to share your imagination. So we live today in a very connected world, right? Online social networking. In fact, my brother is interning at Twitter right now. So I got to, on Wednesday night, I got a tour of Twitter. It was really quite fun. But anyway, many of us, I shouldn't say we all, but many of us operate in this online social networking environment where we are able to share and compare ideas. And that opens up a lot of possibilities. Obviously, you know, LinkedIn, Facebook, Twitter, those are very successful things because it has so much usefulness in today's society where the world is becoming flat, right? So if you can bring that concept now to aircraft design and you can start to link ideas from around the world and people can post their ideas and we can start to explore the design space and share and compare. So maybe some company posts some kind of a mission profile that they're looking for and you have some teenager in another country that is bored on a Friday night and decides that they want to design an airplane for that mission, right? They can start to tinker around with this and develop something that then can be sent back, some design for this for another UAV company that has a very specific mission in mind. Anyway, so that's the power of social networking. Second bullet here is that I estimate there are about 2,000 aerospace engineers that graduate every year from college. I would venture to say that roughly 50% of those, their dream job would be to design an airplane, right? But what are their options when they actually graduate? They can go work for a big boy aerospace company. If they do that, then they're going to be roped into years and years of work before they get to the point of actually being able to design an airplane. First of all, they have to find a company that's designing an airplane, right? And then it's going to take years to work into that position. Those are very coveted positions, and you have to have a lot of seniority before you can get a position like that. So I see a lot of these graduates actually going towards the UAV industry in the next few years, where they're actually, you know, it's a lot more exciting to design an airframe that's maybe a 5-foot wingspan than to design a bolt on some, you know, big military aircraft. You know, that's so much more exciting. So I think that they are going to start to move in that direction, and we're going to find a lot of those people ready to enter this UAV market in aircraft design. Final bullet I already touched on. If we can open this up and make it a social network, then we can share and compare ideas and start to explore the design space. So anyway, number 2, community interaction is vital as we move forward with the UAV design. Number 3, immediate feedback, learning by doing. Much of the software that was designed for aircraft design was built before computers became extremely fast. And so it wasn't actually streamlined so that it gave you the answer while you're putting in input. And I believe that we can actually close this loop. You know, computers are so fast, and we have the resources now to be able to put in a design and get immediate feedback on how that design affects the mission, or the endurance, or the handling qualities, the stability of this aircraft, all types of things. You can get immediate feedback on if we streamline the process. So this image over here on the right is an aircraft called the Bat, and it was designed by a friend of mine named Denahe. He's 15 years old, junior in high school, and I gave him some software that I wrote in grad school. It's just some software you can kind of tinker around with aircraft design. And so I gave that to him, and about a week later he came back to me with this design. Now, that's a design I would not have come up with on my own, and I have a couple of concerns about it. But what I want to point out is that this has a lot of imagination in it, right? This is a 15-year-old who you know, maybe plays some video games, and he was able to come up with this design, which is really quite a creative design. Now, what if he had not only this software to put this idea you know, into the computer, but what if this software also gave him immediate feedback on the endurance of this aircraft, or the max payload capability of this aircraft, or maximum range, right? And maybe he could play with changing the wingspan and find that actually if he makes the wingspan a little bit bigger, that his endurance goes up, or his drag drops, or his performance increases somehow, right? If he had that immediate feedback, then suddenly this would become a learning tool where he's learning how to design an airplane from this tool, right? Anyway, so that's my second point here, is that if we can give this immediate feedback, this becomes a teaching tool for those who are designing aircraft. Now you can understand that increasing the wingspan increases your endurance, and you can go through the math to prove that. But how much more, you know, a lot of us are visual learners, where you put in something and if you have that immediate feedback, suddenly that makes sense, right? So that's something that you would walk away with and learn with over time. Maybe switching out to a different propeller or a different motor, a drop-down list of available propellers and motors, and he could see that switching to this other prop gives him better characteristics in a certain way. Anyway, this type of feedback is what I'm talking about. The last point here is capturing creativity, and Ken Robinson has given several TED Talks on education, our educational system, how actually the way that it's set up maybe stifles some of our creativity, and over time we lose some of our creativity because we're taught what we can't do instead of leaving the doors open for what is possible. And I'm not advocating, I'm not sure that I agree with all of what he proposes, but I think he does have some valid points that if we can capture some of these ideas at a younger age, that they can bring ideas into the UAV design space that we who have maybe studied this a little bit more would overlook because we've been taught that that's not the right way. So anyway, immediate feedback is fundamental here. If we could capture that, then we can capture this creativity and turn this into a learning tool for the younger generation. Okay, number 4, technical data. Who here has been present when an autopilot was turned on for the first time? You went from pilot in control to computer in control. Anybody been on site when that happened? What kind of anxiety was in your stomach as that happened, right? That's we're very anxious when that happens, especially when it's our electronics or the electronics that we pay for out of our pocket that are flying on that thing, right? Anyway, why do we put ourselves through that? If we had a tool that once you put in this design, out came maybe some control log for our autopilot, you know, as an initial guess. Now, it's not going to be perfect, we're going to have to go up and tune some games, but at least it gets us within the realm of where we need to be, and so that greatly decreases our risk for these initial flight tests. Maybe further, you could put it into a flight simulator. You can hook up your autopilot straight to that flight simulator and fly this thing. And that gives you the opportunity to test out your algorithms, different things, control a lot of things before you actually put hardware in the air, right? Anyway, so I think this technical data is something that has to be in place, that this package, or the design tools that we create in the next few years have to give us real-time feedback to our autopilot and control algorithms so that our algorithms can be learning things before we put hardware up where it gets really expensive. So that's the technical data, try before you buy concept. All right, now the final point I want to make is rapid prototyping, and I call this seeing is believing. And all of us have probably seen a 3D model on our screen, rotated around, tried to make some design, and there's something different about having that 3D model actually in our hands and being able to hold it. And we see different things than we see on the screen. Same idea when maybe you wrote a report or a memo or something, right? And you had proofread it a couple times maybe, and you clicked to print and you walked over to the printer and you pull out, and the first thing you see is that misspelled word, right? For some reason, our eyes are able to pick up things in reality different than when they're just simulated on a computer. So this hands-on feedback, I think, is an important thing, especially as we talk about mission-specific airframes and some of the problems that we're going to have to work out with designing these mission-specific frames. Second is decreases build times, and number 3 here, rapid prototyping. I've got a friend who he's into this 3D printing stuff, and I think that's going to be really key in the next few years, the capability to design something on one side of the world, send a plan to the other side of the world, and within a matter of minutes that person is printing this object that was designed somewhere else, right? So he actually builds 3D printers and sells them, but he's printed a lot of parts. In fact, he's printed his own quadcopter. He bought the arms and the propellers and motors and electronics, obviously, but then the rest of the parts he actually printed and flew this thing. And I think that's going to be game-changing in the next few years. The capability to print these things anywhere in the world, and for anybody to design something, put it up on the web, and minutes later have that design in different countries being printed for a specific mission. So actually last week, Quartz, QZ.com here had some article about how 3D printing is going to explode in the year 2014 because of some key patents that have expired. Anyway, so I think that's a capability that we need to keep in mind as we look at the future of UAV airframe design. So that's my last point there, rapid prototyping, seeing is believing. That's something that will be game-changing in the next few years. So I'd just like to summarize what I've covered here. Number 1, there's a shift in aircraft design from the big boy aerospace to all of the UAV startup companies that don't have the funding or the resources to come up with the software and design methodologies on their own. And so I think it's a real opportunity for those who are into aircraft design, and like I said, I'm biased because this is what I think about. So anyway, I just get excited about the opportunity that lies ahead of us here as we move into the UAV world. The 5 key components that I think these new tools will have as we move forward are they will be user-friendly, allow community interaction, provide immediate feedback, produce technical data for the autopilots, and offer rapid prototyping options. And if we can do that, these are the benefits I see to the UAV world. Providing mission-specific airframes, which is going to be a growing need. Capture the creativity, exploring the design space, iterating cheaply on designs, and then safely being able to flight test. So I'd just like to end with one more quote here by Roberto Clemente. He said, if you have an opportunity to make things better and you don't, then you are wasting your time on Earth. And I think we're all in this room today because we see an opportunity to make something better than how it's been in the past. And anyway, I hope in my small way I can contribute to this community over the next few years in making aircraft design methodologies better for the UAV industry. So with that, thank you for your time, and I'm happy to answer any questions.
being able to do something which computer horsepower has enabled us to do probably in a much more economical way nowadays, which is to do the actual like aerodynamic modeling and testing that would typically require, building prototypes using wind tunnels, iterating lots of measurement. And needless to say, if that can be done in software, that can save a tremendous amount of time. But where are we at in terms of actual software capabilities? I mean, in your work, you probably have access to some of the most exotic tools, and some of that's probably stuff you or others have written. How close to the actual physical world can you model, or could you expect to model? Certainly not on an iPhone app, but with a reasonably powerful desktop computer.
Yeah, that's a good question. So when I was in college, we did some modeling with some pretty basic modeling software, and we actually got within about 2% of the capability of the aircraft. So we predicted the endurance of this flying wing to be 2 hours, right? That was our goal, and so we had designed this for 2 hours. We took it up for the initial flight test, and we flew for 2 hours and 1 minute, and we came down with a depleted battery just enough to keep the autopilot running, right? So I think there are methods that get us really close, and then if you want to get the last couple percent, you have to go to higher order CFD methods. And those are really computationally expensive, even today. That's still a challenge. But they're actually getting fairly accurate. So that's going to continue to change, right? I mean, as we move forward, the CFD community actually is growing very rapidly.
Sorry, what is CFD?
CFD, I'm sorry, computational fluid dynamics. So that's the software that will predict the aerodynamic capability of some object, right? So anyway, we see those capabilities growing rapidly, and right now we can get within a couple percent, and that will just continue to get better.
You mentioned specific comments. Can you add a little bit about where you see the multidisciplinary optimization going and how that fits into here?
Yeah, that's a good question. So MDO is a tricky thing because you generally, in optimization, you need a single, they call it a fitness parameter that you're trying to optimize towards, right? Well, generally, in this type of a thing, we have a mission that we're trying to optimize. We don't just have a single point. If I want to optimize on endurance or on range or something, that's a single point. But actually, with these missions, we have some confined takeoff space and room for landing. Anyway, we have several factors that go into that mission planning that all have to be met, and then you're trying to optimize on top of that. So it becomes kind of a tricky thing. But I think as we start to focus, if we can open up the design space to people who haven't studied this necessarily, but have the tools to be able to play around with that, then you get their ideas, and you start to capture everyone's creativity rather than trying to make a computer solve the optimization problem. I think man is still better at that in some aspects, right? A computer's really good at going after a single answer, but in order to capture some of these broader optimization problems we have, I don't think the computer algorithms are there yet. And so I think we have to rely on humans who are iterating in a sense. I don't know if that answered that question, but that's the best thing out there.
Yeah. Just a comment instead of a question, like you were saying about harnessing the capacity of everybody on the internet essentially to be able to design things. I know in the biotech industry they've already kind of done that with computer modeling for protein and chemical combinations and whatnot that computers are incapable of solving. They basically made a web game out of it and pushed it out to the internet, and individual users are scored based on different protein combinations, and they're able to solve these impossible problems and figuring out disease processes and protein combinations for new drugs in weeks instead of dozens of years.
Yeah.
So essentially, the model for what you want to do is already there.
Exactly, and I agree with that. And actually, that's one example that I've thought a lot about. If you can form this, in the first weekend that Halo 3, I don't know, I'm not a computer geek guy, but something came out. There were 10,000 man hours played, right? Or I'm sorry, 10,000 man years played in one weekend, right? When a game came out. There's a lot of time out there that people spend on a computer doing things that maybe are not as productive as they could be, right? So if you can form this problem in something that catches their attention and requires some creativity, I mean, that's exactly what the bio industry did, right? They put out some model that allowed people to play around and made it into a game, and they were able to solve some really complicated problems. If you could design it like that, then you could solve some really tough challenges that are coming up. Excellent example.
Thank you, Dan.
Okay.